Section 3.7 is optimization problems. We're going to look at taking calculus and use a little bit more of a real-world approach and apply some of what we've learned about mins and maxes and all that stuff into a real-world application. So this is going to be a story problem section here. And what I want to do is I want to give you a strategy for solving these problems. These strategies right here for an optimization problem. All right, my first thing I'm saying is I'm gonna draw a picture, and I'm gonna assign symbols for everything that needs to be found or needs to be determined. Then I'm gonna write a primary equation. A primary equation is what we are minimizing or maximizing. What we want to minimize or maximize is our primary equation. Then in most cases, our primary equation is gonna have two variables. If it has two variables, we need to reduce that primary to just one variable by using a secondary equation. And what a secondary equation is probably some stipulation that the problem gives us that we have to abide by. If you look down here in our next example, and we'll get there a little bit, it gives us a stipulation that we can only have a surface area of 108 square inches. That's going to be a secondary equation. You'll see that here in a little bit. Our fourth step then is to determine the domain of the primary equation. And then the last step is to find the maximum or the minimum values. All right, using the first order derivative test, and we know how to do that. So here we go. Our first example: a manufacturer wants to design an open box having a square base and a surface area of 108 square inches. What dimensions will produce a box with a maximum volume? Well, first off, what we need to do is we need to draw a box. I got that with my word drawing here. And we need to label what we need to know. All right, it says we're designing a box with a square base. So my base is going to be some x by x, some length by the same length. All right, some same number. And my height, we don't know. We got to figure out what my height's going to be as well. So my h. So we have some box x by x and a height of h. Okay. And then, so we drew our picture. Now we need to determine what are we going to maximize, what are we going to minimize. Well, if you read the last sentence, what dimensions will produce a box with a maximum volume? So we're maximizing our volume. So we need to write an equation for volume. And remember, volume, any type of shape is the area of your base times your height. Well, the area of my base is x by x. So x times x is x squared. And multiply it by my height, which is h. So that's our equation. There's our primary equation. Step number 3 was to eliminate one of those variables. We wanted to not really eliminate, but we want to get our primary equation to only have one variable using a secondary equation. And remember what I just said. I said that it's some stipulation that this problem is going to give you. Well, they gave us a stipulation that our box can only have a surface area of 108 square inches. So our secondary equation, we better write the surface area equation. Well, to find surface area, you find the area of every side of the box and add them together. So I'll find the area of the bottom. Then I'll find the area of this front side. And then the area of the back side back here. And then the area of the left and the right side as well. And that'll give us our surface area. If you note, if I want to find the area of the base, so it would be x by x, right? That is x squared. If I want to find the area of the front side and the back side, they're going to be the same. If I want to find the area of the front side and the back side, up here, here's the front side, it's going to be h by x, so plus h times x. And you'll notice, actually, the rest of them are also going to be x times h times x, and so forth. So we're actually going to have 4 sides that are x times h. That is our equation for surface area. Notice we didn't find the area of the top because in the problem it tells us an open box. So that means we don't have a top. So we're going to go ahead and plug in our stipulation. Our stipulation was 108 square inches. So our surface area, 108 equals x squared plus 4xh. Now we have a choice. Now since we have a secondary equation, we have a choice. We need to solve for one of the variables and then plug it back into our primary equation in order to eliminate a variable. I think in this case it's going to be easiest to solve for h because we have an x squared and an x. So let's just get h by itself. let's solve for that. So I'm going to subtract my x squared over. I'm going to divide by 4x. So I'm going to have 108 minus x squared divided by 4x, and that equals h. And what I'm going to do is I'm going to take this now, and I'm going to substitute into my volume. That way, I'm just going to have to deal with x's, and that's it. So my volume now is going to equal, x squared times 108 minus x squared all over 4x, and that's it. So there's my volume. Let's simplify. Let's distribute my x squared. So my volume is going to equal 108 x squared minus x to the fourth all over 4x. Since each term has an x, we can cancel one of those out with each of them. So this guy is gone. This becomes a 1. This becomes a 3. Let's go ahead and divide by 4 in each of them too, and we'll finally have our equation for volume. So volume is going to equal 108. Oh, sorry, I was dividing by 4. That's where I got lost. So 108 divided by 4, which is just 27. So I'll have 27x minus x to the third all over 4. Now we're finally done. Okay. The fourth step was to look at our domain. So our domain is, well, what's a feasible answer? We know if we're dealing with dimensions of a box, we can't have a negative value for our box, can we? We can't have a negative dimension. So we know that our choices are going to be bigger than 0. All right, we also know that our surface area has to be less than 108 square inches. 108 square inches. So I'll just choose one side, and that was our base. So we know at the very least if one side took up 100 square inches, then we'd be in trouble. So let's just take the square root and solve for our very biggest, just one side of our base, which would be the square root of 108. So our values have to be in between 0 and the square root of 108, which is a little over 10. So we're looking at only values from 0 to a little bit over 10. And where I got that from is that stipulation, again, that the surface area put on us. Yeah, I hope that makes sense. I just chose the base and said, well, if our surface area of my base equals 108, all right, that's the biggest that we can have. We wouldn't be able to have any other sides. So that's why I did that there. So now that we found our domain, here's our domain that we're dealing with. Now we can maximize our volume. And to maximize our volume, we're going to take the derivative. We're going to find a critical point, and we're going to see what happens. All right. So let's take our derivative of our volume. So dv dx, the derivative of our volume, equals 27 minus, we'll bring down my 3, so it'll be 3x squared all over 4. So there's the derivative of my volume. Let's find our critical points. So 0 equals 27 minus 3/4 x squared. Add 3/4 to the other side. 3/4 x squared to the other side equals 27. Let's multiply then by a 4/3. Multiply by 4/3, so that cancels out. Now this goes into it 9 times, I believe. So we get x squared equals 36. So x can equal plus or minus 6 when we take the square root. Notice now our choices now for our maximum, we have 2 choices, and it's kind of nice. Our domain is going to eliminate one of them. So we just have a choice of x equal to 6 for our critical points. We really don't need to plug it into the first or second derivative test because it only gives us one choice. So x equals 6 is our best option. So if x equals 6, all right, we need to figure out what our other. So we're going to have a 6 by 6. And then we can figure out what our height needs to be. All right. The reason I picked positive 6, by the way, is because negative 6 doesn't fit in our domain. 6 is our only option. So we're going to have a 6 by 6. And then to figure out what our height can be, since we'll go back to our surface area stipulation here. Let's go back to this and let's say, okay, so if I plug in 6 for x, let's figure out what h is. So where can I do this on my board? Let's do it over here. 108 equals 6 squared plus 4 times 6 times h. 6 squared is 36 when we subtract that over. And then, so we'll get 36 plus 24h equals 108. If you subtract 36 over and divide by 24, we get our height to equal 3. So to answer this question, our dimensions are going to be 6 by 6 by 3. These problems take a little bit longer, so I'm going to break these up into separate videos. We'll see you in the next video.